In this video, we're going to go over making a 2-channel tube support plate suppression mix for testing tubing. First thing I'm going to do is collect some data from this cal standard. And let's go take a look at what we got so far. All right. So the first thing I'm going to do is go to my strip chart. And let's see, I'll put channel 1 up there. Channel 1, I got 500 kilohertz. And then my cal standard, I can probably get rid of some of these channels because we don't need them all up here for this demonstration. I really just need a couple. So in our cal standard, we've got 100, 60, 20, and then we've got 180, 60, 40, 20. And then there's a tube support plate in there. So let me narrow down on that tube support signal a little bit. So we're only looking at the tube support, okay? Now, why do you need a mix suppression channel when you're inspecting tubing? Well, if you have flaws that are coincident with support plates, they can easily be masked by the tube support plate signal. So if you look at your strip chart, you can see 180, 60, or 160, 20, whatever's in there. Maybe it's 180, 60, 40, 20. Tube support, right there. That's what we got. So 5 flaws in a tube support. But notice how big that tube support plate signal is on your strip chart. Now, if we go and look at a couple of our channels, this is 500 kilohertz right there. That's 200 kilohertz. There's 150 kilohertz. There's 100 kilohertz. Very large signal from the tube support plate. So you're not going to find a tiny flaw there on any of those channels. But we can make a mix. I just got to figure out where it is. Perform mix. So to perform a mix, the first thing you have to do, and every software is a little bit different. This is an older tester. It's a MIS-27. So I just have to go down to the bottom of the screen here and select which channels I want to use for the mixers. So channel 1 is going to be our primary or our keep channel. And then channel 2 or channel 4, so that's going to be the quarter prime or the prime frequency divided by 4, roughly. That's going to be our subtractor frequency. So that's going to subtract the effects of the tube support plate. And to perform a mix, what you want to do is you want to always null in a good section of tubing, which is about there. We can discuss that more later. And you have to have your mix channel, at least on the MIS-27, you have to have your mix channel displayed up here in the top left frequency. And then you just go down here and I gotta find out where it is. Perform mix, voila. See how that tube support plate signal disappeared? So now I'm gonna go over to my other strip chart and I'm gonna put the mix up in there. Now I haven't calibrated the mix yet, so that's gonna be important. Since I have my mix channel here, I'm gonna go back down to my 100% whole, which is right there. And I'm going to set the rotation. So 100% ASME whole is roughly 40 degrees. Now, if you look at the channel 1 strip chart, which is right here, you have a very large tube support plate signal. I can also demonstrate that by flipping back over to channel 1 here. Let's go up and visit the tube support plate location, which is right there. See, on channel 1, you still got a large support signal, but if you flip over to the mix channel, it disappears. So if there was a flaw at this tube support location, you would very easily see it on your mix channel because you have canceled out the effects of the tube support plate. I can go back and turn my span a little bit lower for the mix channel. And look at the strip chart for the mix. You can still see all your flaws clearly, but the tube support plate basically is deleted or suppressed. If you look over at channel 1 of your prime frequency, you still see the tube support plate. So what you'd want to do is you would screen the free span portion of your data, often with either your prime frequency or your F90, which is roughly half of what the prime frequency is. And then for tube support plate structures or anti-vibration bars, you would use mix 1, because that's going to give you a better chance of finding flaws coincident with supports. So there you go. That's a very simple 2-channel differential mix suppression for canceling tube support plate signals.